So, Mrs. Brown here for a quick overview about what we've talked about with light. So, we know from going into the closet with the red apple that not only can we not see that an apple is red if there is no light, but we cannot see anything if there is no light. So, if we are going to model color and how color works, we have to always start with a light. What kind of light? It could be a light bulb, it could be sunlight, it could be any form, okay? And we looked at these through a gradient and we realized that white light is actually made up of all of the colors of light. So, what happens? Why is the apple red? Well, when the light hits this red apple, all colors except for red are absorbed. So, red is reflected and all other colors are absorbed. So I would say, if I were going to write the whole thing, absorbs all colors except for red. So what actually gets to the eyeball? We would only get the red wavelength because red, again, absorbs all colors except for red, which it reflects. Again, that's related to why are these colors different? It's related to their wavelength. So we also looked through some filters. So in this case, say we had a light bulb, and that was our source of light. Because remember, again, we always have to start with a source of light for anything to reach our eyes, okay? So if we look at the sun, well, you don't want to look at the sun, obviously, but if we look at a light bulb, it's going to produce that light that it is actually converting from electricity. So if we are not looking at a light source, how do we see light? Well, we see it because, as with the apple, it reflects different objects, reflect different colors. So what if we just had a white piece of paper, like the piece of paper that I am looking at right now? Well, the fluorescent lights in the classroom are coming down and hitting this, sending the whole spectrum. And what is white? White is actually a reflection of all the colors. So all of these colors come down and hit white paper and are reflected. And that's why it appears white, because white is made up of all the colors. Now, what if between the paper and the eyeball we have a filter? Okay, so we had like a filter that was red. Okay, so if you look through a filter, a filter filters or takes things out, right? So a red filter, if you look through it, everything looks reddish. So it transmits red or allows red to go through. So all these colors come up here, and what's the only one that can get through? Is the red one. So what does the paper actually look like? So the paper, even though it's white paper, it looks red. Why? Well, the filter transmits red and absorbs all other colors. Okay, let's try. So this time we'll have the fluorescent light from the classroom. All right, that'll be our light source. It could be a flashlight, right? It could be anything. And if it's white light, we know that it is emitting all the colors in the spectrum. And let's say this time it hits a piece of black paper. What happens? What is the color black? Anyway, so black paper, if I have a black marker, it actually absorbs all light. So when light hits something black, all colors are absorbed. So is anything reflected back to the eye? No, nothing at all. So no light, in this case, that's being reflected back, means it looks like the color black. Just like, as I mentioned earlier, when we went into the closet and turned out the lights, everything literally looked black.